Bismillahirrahmanirrahim. Our research title is Spatial-channel attention-based stochastic neighboring embedding pooling and long short-term memory for long nodal classification. Our outlines in this presentation contains introduction, problem statement, method, experiments, result, and conclusions. We will start with an introduction about the lung nodal. The lung cancer. The lung cancer has become a serious threat to human health. In World Lung Cancer Day 2019, American Lung Association (ALA) reported that lung cancer is the most common cancer within about 2.09 million new diagnoses each year. Lung cancer responsible for most cancer death, about I think a 20% of other cancers person die according to a World Health Organization. The causes of lung cancer is smoking, airborne toxin particles, aging, and genes extra. Unfortunately, those who are specialized in discovering practical ways to control cancer are not able to find a cure so far. Diagnosis of lung tumor is an important area of the research that researchers are working on for over 20 years. Chest X-rays are the first step in the assessment of symptoms identified by someone who may have symptoms lung cancer. X-ray X-ray can provide some information about more detail, but more details are required to diagnose the lesions properly. CT scans were introduced in 1970 and has become an essential mechanism in medical imaging. Medical imaging is foundation of advanced healthcare given different diagnostic and frequently curative. CT scans present the anatomical and valuable information about the construction and physiopathology. Attention mechanism can locate and extract adequate information for medical images. Attention-based pooling has become emphasized lately, averaging, maximizing, minimizing the interested area could properly consider the channel global attention. The CT scans are constructed from the slices arranged sequentially to build the volumetric shape for the lung nodule. Averaging, maximizing, minimizing the interested area, and most of the spatial attention is performed deterministically or locally without considering the long-range dependencies property of the lung nodule. The long-range dependency is the one of the CT scans properties. Handling lesion size and location variance in lung within the lung nodule are one of the main shortcomings of traditional convolutional neural networks. The pooling layer within the CNN reduces the resolution feature maps, causing small local detail loss that needs processing by the following layers. The contribution of this research is a novel stochastic. The contributions are novel stochastic neighboring embedding pooling is proposed that can investigate additional discrimination for long-range dependencies and work as a stochastic downsample operators. Attention-based SNE pooling and LSTM neural network is proposed that can handle the spatial and channel attention for lung nodal classification. In the method, we will start with the SNE pooling layer. The SNE pooling layer consists of, if we have a feature map with the size of HWD, let's consider one feature map. Of course, um, this is a tensor, so that's when we consider one tensor. Each region, if we have 2 by 2 window, then we will consider a subregions with k by k by d. D here is the depth of the length of the volumetric nodule. So we'll have 4 regions here. the first one in the yellow. After the second step, we will flatten each subregion into D features. So each subregion will have D features. Each feature, of course, will contain a number of elements. Here we are considering 2 by 2, so here is 4 element D features. In the next step, we will consider the distance matrix between the features. So we will have D by D distance matrix. After that, we will consider the joint probability. Uh, then we will create our new space with a specific sigma, and then we will use our cost function, which is KL function. Let us see the steps here. The feature maps is contain of one tensor here is h by w by d. Then we'll consider subvolumes each of k by k by d. Then flatten the subvolumes. Then we will have k by k by d. Each will have d features, each feature with k by k elements. Then the distance between x and xj's will be considered here according to this equation. After that, d by d distance matrix will be computed between each element. The joint probability will be computed according to this equation. Then we will create our own the new space q with 1 by d, 1 by d, 1 by d. Then this will be created according to this equation. Here if we see the difference between two equations, the first, the sigma are different for each subregion, but here we just remove this because it's equal for each for all the space. This equation KL is our cost function, which need to minimize using gradient descent to get our last downsampled vector. Let's now talk about our model, which use the snip pooling. Our snip pooling, our model attention-based snip pooling contain of h by w by d nodal volume. We will start with we will have uh, 3D convolutional layers, each with C channels. Here C can be any number. Of course, this is just a placeholders. It can represent any number when we need to embed the first volume space to different number of spaces or channels. Then between each 3D convolution layer, we can add our snip pooling to consider the spatial attention between the nodal volume slices. The first So we'll have firstly a 3D convolution layer, three snip pooling layer. We can see here the volume space are the same for the first snip pooling, the second snip pooling, the third snip pooling, the last snip pooling, which is here. We can see that the W here, the volume space uh, it is just like the same volume for each feature map. So the output of this will be a vector with 1 by d for each channel. This is the difference for between this SNE layer and this SNE layer. So we will have C number of feature vectors, and then to consider according to this vector, this is the output of a spatial attention. To consider the channel attention or global attention, we will use LSTM unit. How many units? Here is C LSTM units. The first start C1 till CC. So this is LSTM, is type of sequence to 1. So the output of these LSTM's unit will be scalar of C1, C2 until CC. So these are the feature because there is a feedback between the output of this to this. This is our connected here. This is represent to the global feature attention. After that, we will feed this to fully connected layer with softmax, which will classify the nodules into malignant and benign. Our experiments have been done on two types of data set. The first LIDC, the second is a LangX data set. We have trained our model with LIDC with 80% of LIDC, and we have tested with 20% of this. Of course, we have used k-fold validation. After that, we use a LangX dataset to just for testing, just to see our model how it work when it tested under unseen dataset. Our result we can see here. This is all these methods have been used pooling attention. This is attention based pooling. So our model have the best performance when we use the second table refer to the proposed model, proposed model with the state of the art. So these are different type of attention methods. We have the 3D axial attention and broken and U-shape and multimodality, which use BET and CT, and different modality can be used here. We can see our model is the best result have been obtained from the testing here in terms of accuracy, sensitivity, and specificity. Then this table refer to the different model, which these models are 3D axial, broken, and U-shape, have been used in our previous paper, which have been published now in Q1 paper. This is we have tested these under LIDC. We have trained these under LIDC and also tested under LIDC. And then we have tested under using LangX dataset. If we see, our model have obtained 84.9 with unseen dataset with LangX. And also the second best one is broken here, have been proposed by Mr. Al-Shabi recently, also in 2022. These two methods, this is just like a baseline methods. Here the visualization of ROC for our model based on LangX and LIDC. Here the ablation study based on different pooling, and here based on different number of SNP pooling. Of course, here 4 SNP pooling can be obtained, best result can be obtained. Here is the visualization using a GradCam and guided GradCam for 3 baseline method, broken and not the 3D axial. We can see our model is the have more concentration on this is a this is a this is a malignant nodule. This is a benign nodule. We can see our model more concentration on the nodules than others. Um, this is just like for interpretability measurement. In conclusion, then 1 minute I have. Then this pooling is applied to the proposed model that have been trained in an end-to-end from the attention, fine grain, and more discriminative feature. We run extensive experiment to show the performance of the proposed model. We plan to use generative adversarial GANs in future work, which can consider even the undetermined nodule labeled as ambiguous malignancy. Thank you so much.